So dipole moment P is equals to Q D. So we have two charge minus 0.5 picocoulombs, 0.5 picocoulombs. One at minus 1, 0, 0. The other one is 1, 0, 0. So vector D so we have two position vector. This is 1, 0, 0. The other position vector is minus 1, 0, 0. So my vector D will be 1, 0, 0. Plus the negative of this vector. So normally we just write as minus second vector. Okay, so this gives us two, 0, 0. And this is in millimeter. Q is simply 5 picocoulombs. This is 5 times 10 to the minus 12 coulombs. So a dipole moment P will be equals to 5 times 10 to the minus 12 times 2, 0, 0 times 10 to the minus 3. Let's give 5 times. Sorry, my mistake. It's not 5. It's 0.5. So 0.5 times 2 gives us 1. 10 to the minus 12 times 10 to the minus 3. This gives us 10 to the minus 15. And this 0, 0. Then the unit will be coulombs meter. Okay, so there's the dipole moment of the two charge of minus 0.5 picocoulombs and plus 0.5 picocoulombs, separated by 2 millimeters between them. And now work out the electric field at a position vector of 2, 0, 0. Summarize the scenario. So I have X, Y. So I have one charge here at minus 1, 1, then 2. Has to work out the electric field at this point here. So we can work out the electric field due to the minus charge in isolations, and then due to the positive charge in isolations, and then sum up the two electric field vectorially. Okay, I'll solve this, and then there are two more similar questions to this, and then you can try that at your own pace, and I give you time for you to submit it on Socrative later on. Okay, so use this as the example, and then to solve the rest of the questions. So at 2, 0, 0 millimeter. So we have the first one, I call it E1, which is due to the one at 1. This E field here. So R1 is equals to 2, 0, 0 minus 1, 0, 0. Give us 1, 0, 0 millimeter. And the unit vector simply equals to 1, 0, 0. The electric field E1, that will be Q1 over 4 pi epsilon naught R1 squared times the unit vector R1. It will be 0.5 times 10 to the minus 12, 4 pi 0.854 times 10 to the minus 12 times 10 to the minus 3 squared times 1, 0, 0. That will give us 4.49 times 10 to the 3, 1, 0, 0 volts per meter. E2. This will be this scenario here. -1, 2. Our vector R2 and E2. R2 equals to 2, 0, 0, minus -1, 0, 0. This will be 3, 0, 0 millimeter. Unit vector of this 3, 0, 0 divided by root 3. This is equals to Q2 4 pi epsilon naught R2 squared times the unit vector of R2. This will be minus 0.5 times 10 to the minus 12.
Sir.
Hello?
It should be 3 instead of root 3.
Yes. Thank you for that. So there will be 4 pi times 8.854 10 to the minus 12 times 3 times 10 to the minus 3 squared times 3. So there will be 100 as well. Okay, so 3 and 3 cancel out. So we have 1, 0, 0 as the unit vector. This gives us minus 4.9 times 10 to the 2, 1, 0, 0. Watt per meter. The electric field be E1 plus E2. Okay, so you work out the total electric field will be 400 kilowatts per meter.